So I'm very nervous because this is the last presentation and I'm seeing some very tired faces here. So it's me standing between you and your dinner, wine, and the tech showcase. All right, so please be kind to me. All right, so my name is Saurabh, and I represent a team called Simulink 3D Animation at the MathWorks. And I'm not going to do a product presentation today because I know you guys are bored. So what we'll do is we'll cover three things. I want you to walk away from this room learning about the state-of-the-art 3D animation for simulation engineers, get an understanding of the approach the MathWorks is proposing to this problem. And the last thing that I'd like to do is motivate you, inspire you to think of ways in which you could use this in your work. All right? A picture is worth 1,000 words. You've heard this again and again so many times. And it should come as no surprise that Simulink is a very popular tool, right? Because it's graphical in nature. Now let me challenge you. Can you tell me what's going on in this model? Anyone? It's a robot? Jim thinks it's a robot. Anyone else? It's a what? All right. All right, so I know the guys at the back, especially from the MathWorks, they'll be saying, well, you got to press the play button, right? And you got to start generating all these graphs, right? For this particular model, you need to generate something like 15 to 20 graphs to really understand what's going on. And I'm not kidding. Because I took a very different approach to this problem, and what I did is I put it in 3D, basically 2D. And this is what this system does. All right, so it's a competition, a game between Spain and the Netherlands for the World Cup, which we simulated in Simulink. And we fudged the numbers a bit, but we were able to predict what the outcomes will be. But quickly you can see that there's some very complex strategies that are in action right there, right? And Walt Disney once said that animation can explain whatever the mind of man can conceive, right? So it looks very promising. Sounds exciting, right? There's one problem. The problem is making 3D animation technologies accessible to simulation engineers is a very hard problem. And we at the MathWorks have been struggling with it. And there's a good reason for it. If you plot the tools that are available in the market, if you plot all the simulation tools versus all the 3D modeling tools, you'll find that Simulink is very good in this particular axis with dynamic simulations. We have a lot of 3D modeling softwares available in the market, a lot of 3D games, and they're very good at 3D modeling. And if you go to Hollywood, they have all these movies they make, right? They're basically specialized simulators, highly specific and very costly. But this has resulted in a chasm between the two worlds, the simulation world and the 3D modeling worlds, all right? And what that means is that if you're a simulation engineer, it's really hard for you to access all the good stuff that's happening in the 3D modeling world, all right? And the other thing that we see in the 3D modeling world, especially from our perspective, is that it's very fragmented. There are multiple file formats, the tools are expensive, it's very hard to learn, especially if you're a simulation engineer. All right? So we at the MathWorks, especially my team, believe that we would like to bridge that gap, bring the two worlds together. And we think it's a very noble thing to do. And let me tell you why. Let me tell you why. Because the engineers of tomorrow, several of whom are not in this room, they're going to be right-brained, okay? And they're going to think visually. There's going to be 3D content freely available on the web. Social as they already are, right? They will want to communicate visually. That's what we believe is going to be a big trend in the future. And we just want to enable that, all right? So I'm going to show you the tooling that we have put in place. This is a work in progress. And every year we keep on adding stuff. But it's a pretty hard problem, so I'll not claim that we've solved this problem, but I want to show you what we've done. So it's a three-step process, which starts with this preliminary step, which is about reusing 3D content, all right? Now, 3D content is available on the web, all right? It's available in different formats, For example, for this wind turbine, we actually took different pieces like the tower, the hub, and the blades. They were all in different CAD file formats. And so the big question becomes, well, how do you mix it? Because they don't gel well. So what we did, we said, well, convert it to VRML. VRML stands for Virtual Reality Modeling Language. It's an open standard. It's a stable standard, okay, and it's widely supported by several 3D modeling tools. They provide you with filters to convert it to this file format. Now, many of you are chuckling at the back, perhaps wondering, well, isn't VRML one of those old standards in the 90s, and it sort of died a long time ago? Well, guess what? We keep hearing all these organizations tout these different standards out there, X3D, but we haven't come across a single standard that is bashed so much, but is still the most stable and most widely supported. For some reason, they hate it, but they still like to support it. So we just like to think like you, like engineers. We like to stick with things that work. All right? So if a standard comes along tomorrow, which is as good as VRML, we'll switch. So once you've converted to VRML, we're asking you to assemble the 3D scene. All right? So all this content is available on the web. Convert to VRML. Bring it in the 3D World Editor. This is the name of our editor that we ship. All right, so the blades, the hub, and the tower are all combined in this particular scene. Don't build it, assemble it. That's the mantra. Add the lights. I'm going through a recipe here, all right, for the simulation engineer. Add texture, basically take an image and just wrap it over the 3D object. It looks like grass from far. Add a sky. I added a dome. I added a picture of the sky on top of it, right? And what I did is we also provide you with an interface where you can take signals from inside the Simulink environment and map it to the 3D object, all right? So there's a sim mechanics model that I'm not showing here from where we generated all the data from for the simulation of the wind turbine, and we just plugged it into that 3D object that we built, all right? So if you press play, this is what you should see, all right? And you'll be wondering, well, that's a lot of steps. How do I remember all of that? I'm a simulation engineer. I love playing with my blocks. Well, let me say this. We've been doing our part. We've been putting a lot of videos online where we build these 3D models and we follow the recipe again and again. All right, for wind turbines, for aircraft modeling, and this is something that's going to be an ongoing effort because we have to teach you how to do the easy stuff, okay? Let's talk about possibilities, all right? I want you to feel inspired. Well, inspire the people outside the room if you can. The first one that I can think of is visualizing 2D and 3D data in Matlab, all right? So we have introduced capabilities where you can take the 3D graphs and the 2D plots and mix and match inside a Matlab figure. That creates some really powerful GUIs for your internal stakeholders. Okay? So this was for a testing track animation that we were plotting. For those of you who work in mission planning, ever wondered how the fuel consumption can be plotted as a function of where you are in your mission, right? So this is a very simple animation that we put together for a customer. He was actually wanting to fly drones, but we can't show it in a public forum, but you get the idea. Heat transfer, right? So if you're trying to model the dynamics of heat transfer for this particular geometry, you can use any other tool out there, generate your data, bring it into Matlab, and just stream it into your 3D animation display, all right? Geometric morphing. How many of you work on wing morphing? Anybody here? Basically, you can distort stuff. Real-time simulations, all right? So that's a robot arm, and there's a controller on the XPC target machine there, and there's some, this is a rapid prototyping loop. And what we're doing is we're taking the data from there and just feeding it back to Simulink, and just animating it. You can see that they are pretty much in sync with each other. All right? This is something that one of our customers put on YouTube. This is the interfacing of the XSense 3D inertial motion unit. And you can see it's pretty cool. All right? Discrete event simulation, right? Transferring boxes based on the velocities of two carriages. There's a mismatch, so there are delays. You could do that with 3D animation. This is something that Eddie, our friend here and well-wisher, gave us yesterday. This is actually a pre-shot sniper detection. Looks like a game, but what's happening here is there is a soldier that's trying to run away from snipers, okay? And the snipers are all marked in red, and the soldier is in blue. And what he's trying to do is come out of this area. He sees this particular sniper and just runs away. All right? Now, if this does not inspire you and you're bored and tired, I think that there's one last video that I can show from Ignacio from the Santa Clara University. And I can't play the audio. Is the audio?
There is an audio.
It's the audio.
Is it this one? Just turn that on. Oh, sorry.
We'll do that again. I deserve another chance. This is Ignacio from Santa Clara University. Produce your own musical. It's a pretty complex simulation if you look at the face of it, but he did a fantastic job in choosing the right music and getting it together. All right, that ends my presentation. Thank you very much for listening. If you have questions, you can come back to the tech showcase and